So this is practice exercise 1, where we get to learn how to make an array list, which is really our first introduction to abstract data types, which is a fancy way of saying data structure. I have defined this public interface IList, and this IList represents a list, which is an abstract data type that has the following abilities. If you're an IList, you can append a value. Append means add a new value at the end. In this case, the only values that we're dealing with are integers. So this IList can only hold integers. We can also prepend. What does it mean to prepend? It means add a new item at the beginning of the list. Append is at the end. Prepend is at the beginning. All right. Also, if you're an IList, you have to be able to insert a new value after an existing value. And in this case, it would be the first existing value that you find. So in our example here, if I wanted, what we did was we inserted a 4 after a 3. So this would have been insert after 4, 3, because the first one is the new value, and the second one is the existing value that you're going to insert after. There's also an insert at, which takes a value and the index that you want to insert that new value at. Notice for both of these, well, more on that later. Let me hold that thought. I also want to remove a value based on its value. So this would be the first thing, the first value that you find in the list. If there are more than one, it would just remove the first one. I want to be able to remove at an index. For fanciness, I would also like to be able to get the first thing out of the list and the last thing. That's what first and last mean. If the list happens to be empty, then this would return null, and that's why it's in question mark. So if the list is empty, then it doesn't have a first or a last. I want to be able to have a property that says, is the list empty, yes or no? So that's what this property is. And I definitely want to know how many elements are in this IList, that's length. All right, we're almost done here in introducing the methods. I would like to be able to know what is the index of the first time that a value is in the list. So in our example here, if we did first index of 1, then this would return 0. If we said first index of 5, then we would return 4. So it's just the index of the first time that you see that value. So it's kind of giving you the ability to search through this list. I also want a contains method that just says, is the value in the list, yes or no? So that would search the whole list and determine, is it there or not? Got a method that clears the list, so just empties it out and makes it so that there's no items in the list. And for fun, a method that reverses the IList. So if we've got this list 1, 1, 3, 4, 5, 8, 13, it would return a new list that's 13, 8, 5, 4, 3, 1, 1. And lastly, I want to be able to get the item at a particular index, and that is this int index, the get index. If the array, not the array, if the list is empty, then it would have to return null. Or if you put in an index that's an illegal value, then we might return null. Or we could throw an exception. And I'll have to see what the unit tests do on that. Okay, do these operations make sense to you? On the whole, they're probably all things that a Python list can do or a C# list can do. And what we're going to do in this assignment is learn how we could create a data structure that provides all these operations. An abstract data type, as the book mentions in chapter 4, an abstract data type defines a new data type that has some operations that it supports. It doesn't say how those operations have to be implemented or what kind of data structure has to be underneath it to make it happen, but just it has to support some operations. And we're looking at the list ADT. So my version here of iList largely came from this list, but I might have added and subtracted a few that I thought were not so good or that needed to be there. All right, so this is what we're doing to implement this idea of a list. And unlike the book, we're going to start with an even simpler example, which is an array list. So in this array list, I'm saying that an array list implements the interface iList. You remember that that says, I'm promising the compiler, I will provide a method definition. I'll provide a body to a bunch of methods that don't have bodies. I guess they just have heads. Right? These are all the methods that need to be implemented, but an iList interface doesn't say how to implement it. It doesn't say how to add to the end. It just says you have to be able to add to the end if you're going to be an iList. Does that make sense? So good question. We're going to dynamically allocate the length of the array. And you can see, as I have it down here, I'm initially creating an array that's 16 things long. When that, so our general plan here is going to be when those 16 spots get full, then we'll double the size of the array to 32. When those 32 get full, then we'll double to 64. And so by doubling, the goal is hopefully we'll end up having enough that fits our size. Notice these two key private fields. This is the magic of this array list. This is the actual like concrete memory that we have to keep up with to make this thing work. So there's an array that I very creatively called array. So this is an array of integers that's going to store the data. I also have this private int length. This is what I'm calling the logical length of the array list. So keep in mind, just like here on the board, this array is 10 things long because I have 0 through 9 allocated in one chunk. Initially, our array in the code is 16 things long. But the length initially, this little l length, is how much? It's 0 because we haven't added anything to it. Does this make sense? So it's like the little l length here is how many things I've currently added. And I need to keep up with that. Every time I add something to it, whether through append or prepend or insert, I'm going to increment the length. Deep down, that array is always going to be at least 16 things long. But not all 16 things are items that I'm intending to store there. But at the beginning, they're all going to be zeros. Does that make sense? So that's why here I set length equal to 0 when we create the array list. All right, so I'd like to walk through some of these methods, starting with append, to show you how this array list works. And then we'll do, I don't know, maybe 20% of this together, and then I'll hand it off to you to finish. Okay. So, what does it mean to append? Is that green visible? Okay. Pretend like we have 8 things. We have 8 spots. This is the array. Yes? We also have a length. And by default, length is 0. If I want to append something, append means add to the beginning or the end. End. At this current moment, the end is the beginning, so it's simple. So let's append, I don't know, Ethan, can you give me an integer? 3. Very strong number. So this is where I should add it. I've put it in this spot in the array. You can kind of imagine, I probably need to keep up with or think about, hey, this is the spot to add it. Once I add it, I need to move the arrow here to say this is where I'm going to add the next spot. And I would like to increment the length to say there is now one thing in there.
Seems like the spot that you added at is the same as the length.
That's an interesting pattern. Let's try and see what happens. I would like to append another number. Bo, can you give me a random integer? Hey. This is the end. This is where I should append it. So I should append it here. I should increment that to a 2. If you want to imagine the arrow there. Now, this is where the next guy would go. This pattern does hold where the length, right, 2, if you interpret the length as an index, it's always pointing to the next one. Yeah? So, appending to this array, in its essence, means store the value in the array, increment the length. And specifically, we're going to store it at the index that is the current value of length. So this is really simple. We can write this in like 2 or 3 lines of code. You ready? So we're going to say the array at length is equal to the value that's passed in. Does that make sense? That's what we just did. Take the value, store it at the spot in the array that's its current logical length. Then we need to increment length, which the C way of doing that would be to say plus plus. Anything else? That's basically it, as long as we haven't dealt with error conditions. But I'm going to come back and deal with that later. So this is append. Append is our friend, because with this array list, we can always easily add to the end, because that's where our blank spots are. Let's jump down to prepend, which seems really similar, but I think is going to maybe be a little bit more challenging. So I would like to, can I just go ahead and use this array as it stands, like it still has a 3 and an 8 in it. Joshua, you got a random number that we're going to prepend? 16. All right, we're going to prepend 16 to this. So what index should get the value of 16? 0. Whenever we prepend, we should be putting in a new 0th index. Yeah? We have a problem with that. What's the problem? There's already a 3 there. So what are we going to have to do whenever we prepend to an array that has anything in it? We're going to have to move everything to the right. I would say we have to shift these numbers. So we've got to move the 8 over 1 to be there. And then we've got to make the 3 over here. Right? Copy that over so that we can drop this 16 here. Keep in mind, on a whiteboard, I erase things, but in the computer, there's not really the idea of erasing. You just put a new value in, and it overrides what was there. Yeah. So maybe I could have drawn the 16 over the 3, and that would have been more appropriate to what's happening. Really, that makes your life easier. When you're coding it, there's no step of erasing. That's just something that we do on the board. So notice, in order to do prepending, we had to shift to the right. How many things did we have to shift to the right? 2. And if we were going to represent that as there are n things in the array, how many things did we have to shift when we did prepend? The length. So in terms of what we were talking about last time, big O, how many steps do we have to do prepend if the length of the array list is n? N. We have to do we have to do a linear amount of work based on the amount of the elements in the array. If there's 100 things in the array and we want to prepend at the beginning, how much work do we have to do? 100. We got to move 100 things over to make a spot at the beginning. If we have 100 things in the array and we want to append, how much work do we have to do? 1. Exactly. So it's constant. So for this array list, what we're going to see is prepend has a big O time complexity of big O of n. Append has a big O time complexity of big O of 1, constant. All right, so let's think about how we can do this prepend. Really what I want to do is shift to the right. And if I could shift everything to the right, let's imagine this step is already done. I've got red squiggles, but I'm going to ignore that. What do I want to do now? Array at 0 equals value. Oh, gosh, I did something. No, wait. Oh, no, okay, I'm good. And then I need to do one more thing. Do you know the next thing I need to do? This is the mistake I always make. What's that? We got to increment the length. Length plus plus. So if you ever add something to the array list, but forget to increment the length, then it'll be like you didn't add it, right? Because you've created an inconsistent state where there's 3 things in the array, but the length is only 2. So if we're doing it right, then it'll say, though there's only 2 things, I'm going to ignore that, anything that comes after it.
Lose the last value.
Okay. I'm going to propose that we make a method called shift right that takes in the index that we're going to start shifting at. I think this will be useful. So in the case of prepend, we want to start shifting right, like from at the 0. Now, when we do this, we can't start here. We got to start at the end so that we don't clobber ourselves. Does that make sense? If you copied the 3 over first, then you would have lost the 8. We got to do it from the end. But what I'm saying is, like, logically, what index do you want to start moving over from? Can you think of any reason why it would be useful to make this a parameter instead of just always starting at 0? Is there a time when we might want to just shift over part of the array list? If we want to insert into the middle, then we don't need to shift all of them. We just need to shift at a particular one. So I'm going to come down here to kind of where I have done all of my public methods. You see I've got a private resize. I would like to have a private void shift right that takes in an int. I'm going to call it starting index. I don't know, if you could call it left index, I don't know what you'd consider that. And what I want to do in this method is move every element greater than or equal to the starting index 1 to the right. We've seen on the board that we've got to start at the end and move backwards. Right. If I do this off the top of my head, I'm confident I'm going to do it such that I'm off by 1. But it seems like I need a for loop, and I need an integer, an index I, and I want to set I equal to the last thing, so like the length, maybe -1. And I want to make sure that I is greater than or equal to 0. Sorry, not I. And I want to say I minus minus. Oh, I missed my I here. That's what's messing me up. So I have this for loop that's going to iterate backwards. I want this for loop to go 2, 1, 0. Only I've forgotten my starting index, so my starting index should probably be this guy, right? That's my stopping condition, is when I hit the starting index. You should have done here. Usually we make for loops that count up, and I want this for loop to count down. Because to do this shifting, I want to do something like array at I plus 1 is equal to array at I. Does that seem reasonable? I have to think through this. Length minus 1. All right, if we've got, in this case, in this state on the board here, there's 3 things, right? 16, 3, and 8. So I want to say that length minus 1 is 3 minus 1 is 2. I want to go one more here, and I want to say the array at 3 is equal to the array at 2. Is that what I've done here? I think so.
Need to do minus 1 on the second one and keep the first one the same? Or is that not matter?
See, the way that I've got it, though, is I start at length minus 1, which is the last element. And I'm taking the last element, as it were, and storing it in the element that comes after it. Now, the big caveat in all this that we haven't fixed yet is, what if I plus 1 is longer than the actual length of the actual array, in this case 8? That's going to be bad. So we're going to come back through here and say, hey, if it is ever the case that adding 1 is going to exceed the bounds of the array, the actual array, not the logical length, the actual length. Does that make sense? Like, if it goes past my extra capacity, then I'm going to have to resize the array. I wrote you a method here that does resizing in a good way, where you just pass in an array and it resizes it to be double its size. What really is going on under the hood on this is it's going to take the array, create a new array that's twice as big, and copy over all the things from the array. So that is work, and it's linear work, because I've got to touch everything in the array to copy it down. But this is a built-in method that is going to do this most efficiently in this one line. So what I want us to think about is, when do we need to resize?
I plus.
If I plus 1 is greater than the actual length of the array.
The thing we're trying to set a value to is longer than the length.
And I wonder, I don't know. I can see this in a couple of different ways. I think I would kind of rather handle the resizing in append and prepend and insert. So here, let's do in prepend, at the beginning, I'm going to check for this error case. What's the if here? If the length, which is the current logical length, is equal to the array dot length, that's the actual length of the underlying array. This would mean, in my mind, this means we're full. The thing is 16 things long, and we've got 16 things in it. Yeah? We're 100% full. What does it mean if we're 100% full? What do we need to do? We need to resize. And I think that resize method takes care of everything. So when we do this, we will now have array will be twice as long, which means it'll have the same 16 things as it had, plus another 16 blank items. Yeah? So now we know, as long as we do this before we call shift right, there's definitely space to do the shifting. We really want to do this exact same thing anytime we add to the array, which would also be in append. So I'm going to go ahead and copy paste it into append while I'm thinking about it. Right, because append is going to add one to the end, but we got to make sure there is one there. Caleb. You don't. For some reason this time I wanted curlies. You do you, bro. You do you. Okay. Thoughts? Feelings? Can you voice concerns or questions you have about what we've done so far?
I think still might be get length array up in the right.
If we want to be really, really safe, we should. You're right. Can you imagine now when are the other times that we might need to resize the array based on this list of methods? We've already addressed these two. Are we going to have to resize the array if we do insert after? Yes? No. If we insert a new value, might we have to resize the array? It's going to have to grow one to insert a new value. If we insert at a particular index, are we going to have to grow the array? Potentially. There's a chance. So for both of these insert methods, we're going to have to, we might need to resize. So I'm going to go ahead while I've got it copied and while I'm thinking about it and put in both of these resize. Okay? Coming back to this guy, if I remove a value, am I going to have to resize the array? No, there's no way it gets longer. It logically gets shorter, and I'm going to say we're never going to resize the array down. Once we've gone up, we've allocated that much memory, we're in. Okay, we're not going backwards. Do we need to resize the array if we remove at a particular index? No, it's not going to get bigger when we remove in either way. Do we need to resize the array if we return a copy of the first element in the array? No, that doesn't change anything. And the last, that's not changing anything. What about if we determine if the array is empty? Is that going to change? Nope. What about if we get the length of the array? Nope. What if we get the first index of a value? Nope, that's not going to change the actual size. What if we check if a value is contained in the array? Negative. What about when we clear the array? It logically changes the value down, but it doesn't change it up. What about when we return an IList that's the reverse of this array? Nope. What about if we get the value, the integer value, at a particular index? No. So the only time this array list can grow is if we append, prepend, insert, or insert, the two inserts. Okay. As we've already pointed out, we made that shift right to set us up. It takes in a parameter to set us up for the insert after. Yeah? Because we're saying if you insert in the middle of it, it's a little bit like prepend in that there are some elements that might need to be moved over. If we happen to insert at the very end, which is basically a append, then we would have to shift over. Okay. What happens if we remove a value? What are going to be the logical steps of removing a value? So let's say I would like to remove a 3. Brandon says we're going to have to shift left. How many things are we going to have to shift left?
Everything right of it.
It is both of those correct. Everything to the right of it, which in this case is just one. So if we're doing remove, we have this opposite operation where I would call it shifting everything left. So we've got to take this guy and copy it to the left. Yeah? Okay, good. And we need to change the length of the list. So if I can, I'm going to propose, sorry, it would be in here. Notice these private methods, the shifting left and right, they're private because they're just utility methods that are helping us do the job of the interface. Other people outside our class don't get to see them or know they exist. They're just private for us to use to get the job done. Okay? So I think we need a private void shift left, and I would also like to have a starting index, although I guess you could almost imagine it's the ending index. Would you rather call it the ending index? You like starting?
Because part of this is the way I'm doing this, we are going to be going from left. It's going to be the start of the thing.
Okay. So you could call this something else. You could just call it index, I guess. But this should shift everything from the end of the array to that index. Or maybe that's off by one. If we pass in 1, I don't want to shift the 1. The 1 is where the last shift happens. Or the first shift. Yeah, in this case we would start. Imagine there's more here just to be clear. Okay, if I wanted to remove that 3, then I need to move the 8 over here first, so that then I can remove the 10, which will replace the 8, which then that next and that next. So in this case, I need to start at the left and move to the right. Yeah. Whereas when we shifted right, we had to start at the right and move to the left so that we didn't lose our values. And I'm going to let you write that shift left. I think I'll let you write the shift left. It's fraught with off by 1 errors, in my opinion. The way I'm thinking about it now is, because these are private methods, I'm going to say whoever calls shift left or shift right is in charge of managing the length. These are not going to manage the length. You could do it either way, but then you've got to be consistent. So can I just like kind of outline here a remove? So if we're going to remove a value, if I could say index is the index. If I were to say this is the first index of the value, you with me there? That's going to be useful information, right? If I'm removing based on a value, I'm going to have to figure out what the index is. I could write that code here, or I could call a method that does that. Notice this method is a method we need to write that we haven't written yet, but we're going to write it. Yeah? So if we have that method, which we will, then we can now, so I lost it, remove. Get that index. I essentially want to do that. I want to call shift left based on that index. And, right, here's our key, the thing that I always forget. If we have logically modified the length of the array list, then I have to modify that little l length private variable. Yes? So I want to say length, what? Minus minus. So in this case, I'm calling 2 methods that don't work yet, so this isn't going to work, but I think this is logically correct if these 2 methods do what they should do. You with me? So this is the outline of remove. Okay. I would love to run through some of these properties that are really, really simple to do. Are you ready? Are you with me? Is empty. This is a property, but I can write it as an arrow function. How do I know if the list is empty? If the length is 0, the logical length is 0, then it's empty. So this expression here, this Boolean expression, length equals 0, I'm saying that with the question. You hear the question, yes? If it's 0, then it is empty. If it's not 0, then it's not empty. So this Boolean condition is empty. Yeah? This public int length, I think this should be a property. What is the public? This is a public read-only property of the length. You can't set the length from outside the array list. What is it? It's just little l length. So notice what we're doing here. This is what will be called encapsulation or data hiding. From outside of the array list, anybody can read how long it is, but nobody can change the length except by methods that we've created, which is appending, prepending, inserting. Those are the only ways to change the length. You can't just say the length is 45. Right? There's no setter on this, which is good because now we can make sure that this thing stays in a consistent state. Okay. Let's do, are there any more properties? All right, let me show you this one because I love this one so much. What does it mean to clear the array? It's like empty it out, delete everything. If we set the length to 0, that will do it. So when we clear it, we don't actually have to delete anything because we're controlling this array list logically. Once we set it to 0, then any data that's in here is junk. It's previous values, and we shouldn't be treating it like it is. Like those are legal values because the logical length is 0. So let's do this thing that I always get wrong, which is contains. I've done this program multiple times, and I've messed it up multiple times. All right, I want to know, in contains, does this array list contain the value? So I'm going to say for int I equals 0, I is less than array.length I plus plus. So I'm going to search to the array, and I'm going to say if the array at I is equal to the value that I'm looking for, then I should return true because I just found it. Yes? If I go through this whole array and I never find the value, then I should return false. You with me so far? So I've intentionally done this with the bug that I make every year. What did I do wrong?
Covering the entire array.
You see this array.length is the entire array. If that's 16 things long like it is initially, this is going to look at all 16. If it's 32, it'll look at all 32. Is that how many things are actually in the array? No. If we just cleared it, then we set length equal to 0, the little l length. So really, this value has got to be little l length, or it could be capital L length, but not array.length. Does this trickiness make sense to you? So in this case, like look at this array. I don't want to look at 0, 1, 2, 3, 4, 5, 6, and 7. 6, 7. 6 and 7 are garbage because the array is not logically that long. So this should be updated to, I guess that would be 6. Does this make sense? Like we see clearly that they're blank, but in reality, they're going to be some number, whether it's 0 or trash numbers that came from before, or they could be zeros that we put in before. Like 0 is a legitimate value that you could store. What's essential is this 6 says, hey, this is the actual length of the array list. Anything past that is just extra and not logically a part of this array list. Does that make sense? Okay, so what I'm inviting y'all to do is to finish this. It looks like I'm giving you a week from today. That's almost too much time, don't you think? It's not too much time? Okay, so a week from today to finish this. Let me show you one more here. I'm going to show you first. So naively, first should be what? Array at 0. And it's pretty much that. What's that? Is there ever a case when this would be untrue? What if it's empty? If the array is empty, then the first thing in it is what? It's null because that's why I made this int nullable. So there's a slick thing called the ternary operator that I think is a good thing to use here. So we can say is empty, question mark. But this is kind of like a one-line if statement. So if is empty is true, then I want to return null from this. Otherwise, you say colon, return the other thing. So I think this is a nice one-line way of saying return null if it's empty, otherwise return array at 0. That's not good. You might have done something wrong then. So I've got, this is an arrow function, so it's as if, like, instead of having to put this in curlies, I've made it like this. I have is empty, which is this Boolean property, which I defined down here, question mark, value if true, value if false. Yeah? So now, probably from this, you could probably pretty easily write last, couldn't you? Yeah. Let me say one more thing before I let you go. This is the mistake I want to make every time. If you remove a value, make sure you decrement the length. Otherwise, you'll get your thing in a weird, inconsistent state where you've shifted values but haven't decremented. Okay? So make sure you decrement length, length minus minus, if you're logically removing. I did leave in here, I overrode to string, and you see this, it has a square bracket, and then it goes to the array and puts a comma space, and then if the array, as long as it's not empty, it adds the last element without a comma space behind it, and then a closing square bracket. So basically, I'm just making it so that if you print one of these out, you'll get something that looks kind of reasonable. You would think like this would be the string that gets printed out. So that's there, so you can just console.log any of these array lists and they'll look reasonable. So you need to finish the missing methods and make them work and make it past the unit test. Let's see how badly I have done here. Does this even build? Doesn't build. Why doesn't it build? Am I missing some stuff?
Seems bigger.
Well, let's look at the unit test. Uh-oh. They must have changed the API. Okay, I got to fix this for you. Apparently, basically, there are some times that you should throw exceptions. Wait, why would it throw an index out of range exception? Oh. If you insert at an illegal value, like a number, if you insert way past the end of the array, if it's 10 things long and you insert at 42, I'm saying that's no good. That's outside the range. If you insert at -5, that also doesn't make sense. And I'm not even going to let you do that. I'm going to say index out of range. So I'll get you a new version of these unit tests. I apologize. Apparently they changed the way to test for exceptions. For next time, make sure that you've read and done the these parts of chapter 4. I guess I really got ahead of myself. So if I can extend it if it makes it even easier for you. So I'm going to say this homework assignment right here is due before class on Tuesday instead of tomorrow night at midnight. So just make sure you've done it then. Happy midterm week. I hope it's treating you okay. See you guys.